So today we are going to construct a RLC circuit. First of all, we are going to search for the V sign. I already find the V sign, so we put it in here. This one is the resistor. This one is the inductor. One more. There are two resistors in this circuit. Then this is capacitor. Okay, don't forget to search for the ground. This one. Okay, so connect all of this. Alright, this one and this one, then this one. So one more thing is we need to find the current and the voltage waveform. So we need to put the V probe and also with the current probe. Yeah, so let's change the value. Go to edit property. The amplitude we need to change to 50 amplitude. The frequency also 50. Show all so that everyone can see lah. Okay, so this one is current, so we just put as V, right? So V, and this one we put as I, because it's easier for you to understand this later on. So of this one we edit into 10 ohm, and this one is in inductor, so later on we need to change this into 5. Then this one is the property 5. This one also we need to change to 7. And G 10 ohm. So this value C1 and L1 later we are going to discuss, and we change it into the inductor value. So this is the circuit RLC, and we are going to identify the waveform of current and voltage, and also we're going to calculate phase angle between I and V. So later on, my teammate will do the calculation. We explain about the calculation and the conclusion of this experiment.
Okay guys, firstly we construct the circle like this, and then following the figure given in the lab sheet assignment. Okay, firstly place the resistor R1 as a 10 ohm, then place the inductor as 0.0159 Hertz. Before we get this, we must calculate the we must calculate the impedance. Okay, as shown below, the L is equal to XL divided by 2 pi F. So the inductance given is a J5 ohm. So J5 over 2 pi and frequency is 50. So we get a 0.0159 Hertz. Okay, for the capacitance is negative J 10 ohm, and then we put into the formula is 1 over XC times multiply 2 pi and multiply with F. So 1 over negative J10 multiply 2 pi and multiply 50. So we get 0.318 millifarad. Okay, so go to this construct circuit, and then you go to the graph mode, analog, and then place the analog analysis. So before we get this, we must do like this. Okay, place the analog, and then click the right click in the black box. So add trace and go to the probe 1, go to V, press OK, then simulate graph. So after we get this, we just setting it at the edit graph. So change to 0.1. So yes, then we get this waveform. So this is for voltage. As we can see, the voltage peak is 50. Alright, then we go at trace, probe 1, and we add a root I. I is for current. Press OK, then same goes to the simulate graph. So okay, and we get a graph for current. Okay, as we can see here, the Imax is at the center of the waveform. So we go to this, and then we can see, so yeah, as we can see, it's a 3 something like 316. So we go to the calculation. So go to calculation, and still like this. So max voltage for the voltage max is 50 volt, and then max current for Imax is 3.16. Okay, to get the time difference is a time peak voltage minus by time peak current. So as we can see here, the center of the voltage peak goes straight to the line x-axis. Here we can see at 45 milli, and then the center for the current is like 44, right? 44 here, 44 millisecond. So as we can see here, I stated 45.0 ms minus by 44, and we get a 1 ms. So phase angle between current and voltage, the formula is a frequency time the time difference time 360 degree. So 50 hertz time it, and we get a 80 degree. So manual calculation for the voltage is a 50 degree, and then total impedance of circuit is a Z equal to R resistance, all resistance in the circuit, and plus with the Z inductance plus impedance of capacitance. So 10 plus 5 plus 4i plus negative 10J, so equal to 15 minus 5J ohm. And for the current is I equal to VR. So 50 over the total impedance of circuit is 15 minus 5J. So we get the 3 plus J ampere, and then 3 degree 18.435 degree. So the current is equal to 3.1623 ampere. And for the phase angle between current voltage is 18.435 minus the 0. So we get the same. So for calculate the percentage of error is calculate value minus measure value divide by calculate value. So as I state here, the percentage error of current is 3.1623 minus by 3.16 divide by 3.1623 times by 100%. So we get 0.0727% percentage error of a phase angle. So the first phase angle that we get is 80.435 minus the real measure is a measure value by we get from this graph is 18 divide by 18.435 times 100%. So we get 2.36%. The value above show that the comparison of simulated value and calculated value are approximately the same. Okay, thank you.
So hi, my name is Muhammad FARHAN ROSMAN. My part is to describe about the discussion and conclusion for this assignment for group 2. Okay, first thing first, we know that the RLC circuit was created by using Proteus in this project, and it was based on the figure 16. The V sign was adjusted to a frequency of 50 Hz and amplitude of 50 volts. In order to mimic the RLC circuit in Proteus, the inductance and capacitance from impedance in figure 60 are computed using the formulas of ZL equal XL per 2 pi f and the ZC for the capacitance equal to 1 over XC multiplied by 2 pi and multiplied by f. Analog analysis was used to analyze and visualize the graph between current and voltage. So after that, the impedance equation is equal to Z equal to V per ampere I was then utilized for manual computation. So as we know, this is figure 16. Yes, figure 16, and as I've said before, XL per 2 pi f, and for the capacitance is 1 per IC multiplied by 2 pi multiplied by f. So after that, as a result, the voltage waveform reveals that the current leads the voltage by 18.435 degrees. And as I mentioned, this is the answer, 18.435 as we got. This is because the capacitive reactance is stronger than the inductive reactance, resulting in Xc more than XL. As the result, the whole circuit reactance is capacitive, resulting in a leading phase angle. When the measured and calculated values of current and phase angle between current and voltage are compared, the percentage error 0.0727% and 2.36% respectively. So as I mentioned, the percentage of error of the current that we got is 0.0727, and the percentage error of phase angle we got about 2.36%. So after that, we move to the conclusion. Finally, we were able to use produce model and build the RLC circuit using the formula ZL and the ZC that I've mentioned before. We can also determine the impedance of inductance of an inductor and capacitance of a capacitor. We drew the graph of the current and voltage waveform, and we can use the graph to determine the phase angle between current and voltage. We also may deduct from the result that current leads voltage by around 80 degrees. As we got before, we got around 80 degrees. Yes, the phase angle between current and voltage, 50 Hz multiply by 1 millisecond multiply by 360 degree equals to 18 degree. Okay, the figure of phase angle between current and voltage has a percentage inaccuracy of 2.36%. The current value that we estimated and acquired from this simulation were almost identical of 3.1623 and 3.16 respectively. The current percentage inaccuracy is 0.0227%. As we got percentage error of current and the percentage error of phase angle, as I mentioned before. Okay, I think that is the last part of my group. So thank you very much. Assalamualaikum.